All right, welcome to chapter 13. In this first section, we're going to look at exponential functions. And for those of you using the ebook, this is in the intermediate algebra text in section 6.1. All right, so our first question says, you have a savings account with a balance of $100. In each scenario below, let B of t denote your balance after t months. And part A says, suppose you decide to start depositing $8 into your account at the end of every month. Complete the table to the right and find a formula for B of t. What kind of a function is this? What can you say about the rate of change of this function? Alright, so since B of t is our balance after t months, and our initial balance is $100, when t is 0, our balance then would just be $100. And in part A, we're saying that we are going to just deposit $8 into our account at the end of each month. So to fill out our balance sheet here, we're just going to be repeatedly adding 8. Okay, so 108, 116, 124, so on and so forth. Okay, so if I wanted to build a equation that describes my balance month to month, well, what I'm doing here is I'm just taking my initial balance of $100, and then I'm adding to that, well, a certain number of additions of this $8 amount, right? So for example, after 3 months, there's been 3 additions of $8. So more generally, after t months, there would be t additions of $8. So this would be my formula for the balance. And I recognize this as a linear function where the slope is 8. So in other words, it's just this dollar amount we're depositing at the end of each month. So that's our rate of change here in our balance. And the $100, that's going to be our y-intercept. That's just our initial balance. Okay. And so for the very last part, it says, what can you say about the rate of change of this function? Well, here, the rate of change is just $8. In other words, it's the slope. So the rate of change is constant. Okay. And that's really what characterizes linear functions. Okay, they're the things with constant rates of change. If you just think about their graph, right, month to month, you're just always contributing that fixed dollar amount. Cool. All right, so now let's go ahead and check out B. So instead of adding $8 at the end of every month, now it says we're going to deposit money into your account in such a way that your balance increases by 15% every month. Okay, so what operation am I going to be applying month to month now if I'm going to be applying a 15% increase? Okay, well, for percent increase, let's say a 15% increase, you're taking 100% of the original amount, and then you're going to be tacking on 15% of that original amount. So in total, you're really taking 115% of the original amount. Or put another way, you're really just multiplying that original amount by 1.15. So here, if I'm going to apply a 15% increase month to month, I'm now not adding, but rather multiplying by a fixed amount, in this case by 1.15. That's going to give rise to a 15% increase month to month. All right. Now we still are starting with a balance of $100 here. And so if I start multiplying, I'm going to get this balance sheet of $100 to $115 and then to $132.25, and then it'll go to $152.09 if I round to the nearest cent. Okay, so on and so forth. And I can see, just comparing these two side by side, it looks like my balance is growing at a faster rate than I'm seeing here for the linear model. Okay. The other thing to point out here is that notice the amount of money coming into the account month to month is not fixed. Okay, so like in this first month, I made 15 bucks. Or sorry, I guess I didn't make, I just deposited $15. But then in the second month, I'm adding what, 1725. And then here I'm adding, it's 1984, so on and so forth. So the amount I'm actually depositing is going up. Okay, so let's make a little comment there that here the rate of change is not constant. Okay, dollar amount's actually going up for our deposits. But on the other hand, although the rate of change is not constant, the percentage change in our balance is constant. It's always 15% month to month. So we can say this, that the percentage change is constant. Okay, so there's that. How about a formula for the balance? B of t. Okay, well, let's say I'm looking at the month 3 balance. How am I getting to 152.09 from this $100? Well, we're taking the initial balance of 100 bucks, and then we multiply it by 1.15 1, 2, 3 times. So I'm gonna, in other words, take the 1.15 and cube it, right? That's the same thing as multiplying by 1.153 times, and then that value would multiply this original balance. Okay, so more generally, after t months, then we're just going to take the initial balance of 100 bucks, multiply by 1.15 t times. Okay, and notice here the variable is in the exponent position, and for that reason we call this an exponential function. Okay, and while again the rate of change is not constant, the percentage change is constant, and that right there is really the key characteristic of exponential functions. Okay, so that's a good place to stop, and we'll pick up with more of this in the next video. Thanks.